Howdy. This short video briefly describes my project proposal for this course. This project is a competition held by Walmart in 2014 as a means to the recruitment process. The project is titled Weekly Sales Prediction of Walmart Stores. Coming to the problem statement, without using any jargons, the project can be explained as training an agent over the history of the sales figures that depend on specific features so that the agent can predict the future sales without any human involvement given a new input feature vector. A sample input feature vector is shown here. It has the store number, the department in which the sales happen, the number of sales, the date, if the date is on holiday or not, or if it's a special sale like Christmas sale or Thanksgiving sale. And once I provide this input vector to my model, which depends on random forest regression and linear regression, about which I am going to discuss shortly, it predicts future weekly sales as my output vector. And clearly this falls under the track of data mining because I am doing feature engineering and I am extracting features that are given in the data, and I am trying to predict other features, example the weekly sales. And I am also using decision trees, which are essentially the primary things in the random forest regression, so it is clearly from the data mining track. Now, why is my project an AI problem rather than a regular statistics problem? Because I am trying to build an intelligent system, which essentially is a motto of AI, and this intelligent system undergoes supervised learning and builds a representation, which are decision trees in my case, that can be used for newer predictions. And it's called supervised learning because the intelligent system cannot train all by itself, and I'm training it using the data to make future predictions. And what category does my project fall under? It falls under supervised learning as discussed in the main textbook of this course, and the reference is given in the end of this presentation. And I'm using these algorithms as shown here, the random forest algorithm. I chose this because this algorithm handles large data sets with higher dimensions. It also handles the missing values and maintains accuracy for the missing data. It also won't overfit the model. And I'm also using linear regression, which is a basic machine learning algorithm. I'm using this as a starting point, and I'm trying to compare the results with random forest regression. Now, coming to the implementation. I'm using Python as my coding language, and I'm pretty much writing code by myself. And I'm using Python because it has a lot of special libraries made for machine learning applications. And coming to the data sets, I have about 115,000 test points and about 420,000 train points, each with 6 features as discussed in the first slide, and the reference to this dataset is given in the last slide. And I feel the number of datasets are pretty much enough to train the decision trees. Now, coming to the toolkits, I am using NumPy, which is a package for scientific computation with Python, Pandas, a data analytics tool, Matplotlib to plot the results, and sklearn is another machine learning tool. And like I said in the introduction, I am also performing feature engineering. Coming to the evaluation, how do I know my project is doing the right thing, it's going in the right direction? I'm using mean square error to compare the performance of linear regression and random forest regression. And I have referred a paper in the end which uses mean square error as a metric to compare to measure the performance of random forest regression. And I'm also using convergence of cost function to see if linear regression model parameters have reached the optimal model parameters. Now, coming to the references, the book by Dr. Anil Maheshwari, The Data Analytics Made Accessible, is pretty much the main source for random forest regression. In the chapter 6, he discusses about decision trees, and in chapter 4, he discusses about data mining, which deals with feature engineering. And the main textbook for the course in chapter 7 deals with the supervised machine learning, and this is the reference link to the Walmart competition. And the paper Classification and Regression by Random Forest, page 1, deals with the algorithm for random forest, and this paper uses random forest and also uses MSE as a primary metric for the performance of random forest. Thank you. This pretty much concludes my project proposal.